Okay, we're doing 5.1 quiz, page 341, geometry, problem number 3. Chapter 5.1, yes. Okay, so what we want to do here is start off, and this is going to be all proper now, right? So like on your test, we got number 1, right? What's number 1 telling us? We need to be able to write this down as a proof, right? So Dutcho, right? Number 1, the first part to our proof is what? Well, how about the stuff that's given to us?
The
right?
side is the side and the angle.
So BD is congruent to CD, right? Because it's given. Okay. We also know that AB is equal to 5Z plus 16 because it's given. We also know that AC is equal to 8Z minus 5 because it's given, right? And we also know that angle BDA is what?
Congruent to
It's
CD.
a right angle.
A right angle.
It's equal to 90 degrees.
That's
Right.
equal to 90 degrees.
And that's all because it's given. Dutcho, given. And we could have made 4. Dutcho, Sally, Shu, and Boosh. But, you know, we'll save some of that because I can only count to 10 anyways. And I need your help to get past 10. So we'll save some of that so that I can actually maybe count each one of these in your language. But that's all given. So it's fair enough to say given, done. Done, 1. I'm trying.
Funny.
So, next step. Sally. Right? Next step is, like we said before, we need to start naming some things. Do we know anything? What do we know?
There's a side.
There's a side? Okay, what side?
Then there's another side. BD and CD are sides.
Well, we have that down.
Oh, and there's that thing in the middle.
Okay? Yeah? What's that thing in the middle?
Reflexive.
Reflexive. So if I wanted to write this as reflexive, that would be AD is congruent to AD, right? That's reflexive?
Yes.
Is that right?
Yeah.
Is that right, Matt?
Yeah. Is it?
AD is congruent to AD because of reflexive?
Yes.
It's DA, isn't it?
Exactly. Thank you, Matt. So no, this is not identity. This is not reflexive. This is identity.
Oh, it's.
Remember, if you wanted AD to be congruent to DA, that would be reflexive. Okay, and that's why I made it a point of saying it wrong. Okay? If you have AD is congruent to DA, that's reflexive. If you have AD is congruent to AD, that is identity. 2 different things. Okay? Still solid. Okay? Truth is what? What's our third one?
Yeah, move your head again.
Thank you.
Not like
No,
that.
not like that. Okay, I tried. Let's try. Yeah, it hurt.
Well, then it will distract me from my work.
All right. What's another thing that we know here? You said it first. The first thing you said was we want to get to side angle side or something like that, right? But we need to know something's congruent, right? We need to know something is a 90-degree angle.
BD.
Something is a 90-degree angle. Where's another 90-degree angle?
On the other side of
C and D.
so BD and CD would be in between CD.
So right here, what would we call that angle?
Line.
CP.
C, D,
Oh, I thought you meant like the thing on the other side.
CDB.
CDA is
FIB.
right, which is also 90 degrees. Why do we know that? Because they add up to be supplementary, right? Definition of supplementary angles. Okay? Alright, boost 4. Right? 4. What's number 4? Okay, so I know I have this angle 90 degree. Did I prove that it's congruent?
Yes. No.
Not yet, right? So now I can say angle CDA is congruent to what angle? BDA, right? Angle BDA, why? Why?
Let's go with the like
Why?
I don't know. I can't see what you're talking about.
Why are these congruent?
Because they're parallel.
Because they're both right.
Part of the alphabet.
Definition of
right triangle.
right angles.
Angles.
Okay? Alright.
Shut up.
Kiko! Again! I'm going to send you onto this site so you can see this.
Gentlemen.
Please! Where is your notebook? You went up to get one.
Question.
Yes.
What does that say after R on number 3?
That just speaks on.
Is it?
Yeah,
that
was
was
RT
is
angle.
that a T?
T,
Is that right?
right, RT, right,
I was just wondering the same thing.
90 degrees.
And the definition of supplementary angles?
Yep. Alright, so we know that these are congruent. We know that these are congruent. Hey, we did this reflexive, right? So we know that those are congruent. So we have what? We have side, angle, side. Is that one of our congruent triangles?
Yes.
Good. So side, angle, side. Right? So I know that triangle, so lots, right? I know that the triangle what? What triangle? ABD? Want to start with ABD? Is congruent to what? So Kiko, which triangle is ABD congruent to? When I'm looking at A, B, and D, how would I say that to this one? How would I say A, B, D? How would I say those 3 letters so that it's congruent?
ABD is congruent to DBA. Just kidding.
Nope.
C
A, C.
A, B, D is congruent to
ACDC.
ACDC. Sorry, ACD. So A, C, D.
That's side equals side.
Do you see that? ACD. See that?
Glad you're hysterical.
Oh God, I'm rolling today.
Pop,
So-
what are these slappers?
I'm glad we're
Huh?
Pop, what are these slappers?
All right. So now, remember what's our next step here? Once I know these, the congruencies of the triangles, what's my next step?
C,
CPTC.
C, T, C.
Yes. Which means
Congruent
Object.
parts
parts.
Triangles are congruent.
are congruent. Good. Congruent parts of congruent triangles are congruent. That means any part to this triangle is congruent to any other part. So So what part is it want me to find?
AC.
AC. The whole point of this is to find AC. Okay? So I need to know that AC, right, is congruent to something. Some other part. What other part is AC congruent to?
CIA.
Well, yeah.
AB.
AB. That's a little bit more helpful. Okay? So AB. And that's the CPCTC, right? Now that I know that, now I can plug it in. AC is 8Z minus 5. So this is Zlotchi.
Yeah.
Sorry. And then this is Oaks. Or oops. Oops. Okay, getting better. Trying. Alright, equals what? 5
5Z plus 16.
plus 16?
Yeah.
Okay, and how do we know 7? What is our rule there?
Definition.
No.
Okay.
Substitution.
There we go.
Substitution.
I knew you guys would get it. Awesome. Alright. So then we have Takachi. Is that right? Takachi. 8. Right? Takachi? No?
Yeah.
Okay. Alright, 8. What do we do with 8? Well, remember in algebra, this is where we would use transition, right? Transition for algebra, right, Matt?
I guess.
This is where we would move the lowest z.
Plus 5. Oh.
You do it.
So we would add the opposite.
Minus 5Z.
Move minus 5z. Minus 5z, right? And we would get
3Z minus 5.
3z minus 5 equals 16, right?
Yes.
What do we call that in geometry, though?
So minus property of equality.
Subtraction property.
Subtraction property of equality. Good. And then what?
Add.
Cool. Is that it? Cool. Right? 9? I'm trying. Okay. So what do we do now? This is back to math, stat map, subtraction property of equality, right? Subtraction, addition, opposite, OPP. How can I explain it? Take it, frame it, right? So we got subtraction property, right?
5.
So subtraction or addition. In this case, we're adding 5, so we call that addition property of equality. So now we have 3z is equal to 21.
Divide by 3.
Snaps. Okay. So now division multiplication, OPP, right? That's what we do in algebra, right, Kiko? Write this down. See, you're doing a really good job at that. Okay. So 10 or salats. And that's where I end with my numbers. I don't have anything after that, but I'll be working on it. Right? Wait. Is this a lot? No, padats. Salats is 5. Padats is 10. I'm working on it. So padats is 10, and then we take divide by 3, and I get z is equal to 7. Right? And it looks like we're done. Well, we're not. What?
You gotta plug Z.
I gotta plug it in. Right? So I gotta come over to 11. Does anyone know what 11 is? Oh, Tootsie?
You have to
11. Right? So now what do? We plug it in. Or we use what's called substitution. Right? And so we know what we're looking for is what? AC, right?
Yes.
We know that AC is equal to 8Z minus 5.
8 parentheses.
So 8 times 7 minus 5. That's our substitution. And so 12 is just simplification, right? And that's 8 times 5, which is 56, minus 5, which is 51. And now I know what AC is. And it took us 12 steps.
You can't just do the algebra, you have to list all this stuff.
I have to list all of it.